Hey guys, it's me again, James Dimaculangan. Today we're going to discuss about the topics in Chapter 5. This video is a summary of Chapter 5 eventually. So I hope you learn something from this. Let's go! The first topic we're going to discuss in Chapter 5 is the Ethernet. The OSI physical layer provides the means to transport the bits that make up the data link layer frame across the network media. Ethernet is now a predominant LAN technology in the world. Uh, Ethernet operates the data link layer and the physical layer. The element protocol standards define many aspects of work communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on Ethernet network, the hosts format the messages into frame layout that is specified the standards. Because Ethernet is comprised of standards at these lower layers, it may best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. Ethernet standards both define the layer 2 protocols and the layer 1 technologies. Although Ethernet specifications support different media bandwidths and other layer and layer 2 variations, the basic frame format and address scheme is the same for all varies of Internet. Now we're going to head out to Ethernet encapsulation. Ethernet is the most widely used LAN technology today. Ethernet operates the data link layer and the physical layer. It is a family of networking technologies that define the IEEE 802.2 and 803.2.3 standards. Ethernet supports data bandwidths of these numbers: 10 Mbps, 100 Mbps, 1000 Mbps or 1 gig, 10,000 Mbps or 10 gigs, 40,000 Mbps, 40 gigs, and 100,000 Mbps or 10 gigs. As shown in the gigs or the MBs, the Ethernet standards define both layer 2 protocols and layer 1 technologies. For the layer 2 protocols, as with all the 802 IEEE standards, Ethernet relies on two separate sublayers of data link layer to operate: the logical link control LLC and the MAC sublayers. Now, what is the LLC sublayers? The Ethernet LLC sublayer handles the communication between the upper layers and the lower layers. This is typically between the networking software and the device hardware. The LLC sublayer takes the network protocol data, which is typically an IPv4 packet, and adds control information to help deliver the packet to the destination node. The LLC is used to communicate with the upper layers of the application and transition to the packet to the lower layers for delivery. And now, MAC sublayer is MAC constitutes the lower sublayer of the data link layer. MAC is implemented by hardware, typically in the computer NIC, that specifics are listed in the IEEE 802.3 standards. Now, next is data encapsulation. The data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of a frame. In forming the frame, the MAC layer adds a header and trailer to the network layer PDU. Data encapsulation provides three functions. Frame delimiting. The framing process provides important delimiters that are used to identify group of bits that make up a frame. Next is addressing. The encapsulation process contains the layer 3 PDU and also provides for the data link layer addressing. And the third one is error detection. Each frame contains a trailer used to detect any errors in transmission. The use of frames aids in the transmission of bits as they are placed on the media and on the grouping of bits and the receiving node. Now, switching media access control. The second responsibility of the MAC sublayer is media access control. The media access control is responsible for the placement of frames on the media and the removal of frames from the media. As its name implies, it controls access to the media. This sublayer communicates directly with the physical layer. Underlying logical topology of Ethernet is a multi-access bus. Therefore, all nodes or devices on a single network segment share a medium. Internet is a contention-based method of networking. Contention-based method means that any device can try to transmit data across the shared medium whenever it has data to send. The carrier sends whenever a multiple access collision detection or CSMA-CD process is used in half duplex Ethernet LANs to detect and resolve collisions. Now we're going to talk about the Ethernet evolution. Since the creation of Internet in 1973, standards have evolved to specifying faster and more flexible versions of technology. This ability for Internet to improve over time is one of the main reasons it has become so popular. Early versions of Ethernet were relatively slow at 10 Mbps. The latest versions of Ethernet operate 10 gigabits per second and faster. Scroll through the timeline to view the various versions of Ethernet. At the data link layer, the frame structure is early identical to the all speeds of Ethernet. The Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. And the Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence FCS field. The preamble field is not concluded when describing the size of a frame. Any frame less than 64 bytes in length is considered a collision fragment or runt frame and is automatically discarded by receiving stations frames with more than 1500 bytes of data were considered jumbo or baby giant frames. If size of a transmitted frame is less than the minimum or greater than the maximum, the receiving device drops the frame. Drop frames are likely to be result of collisions or other unwanted signals that are therefore considered. Okay guys, I think that's it. There's a lot of topics to talk about in chapter 5, but I only take few of those essential topics in this video. So go and check your NetAcad for more info. So thank you. I hope you all learned. Bye.